Dear students, welcome to the course Testing of Fibers and Yarns. And in this course, we are discussing about the fiber dimensions, where we have seen how to measure the fiber maturity and fiber strength, and we have seen the fiber strength measurement by using this Instron tensile strength tester, which works on strain gauge principle. And then we have discussed about the bundle fiber strength testing by means of this stellometer, which works based on the pendulum lever principle. Okay, this is what we have discussed in the last class. Okay, so today's class we are going to discuss about the latest developments in the tensile strength testing. That is, the latest developments in the testing equipment. It is not especially related to the fiber dimension, that is fiber strength. So we can also find out the bundle fiber strength by using this instrument. Okay, but apart from that, so whatever these latest developments in this testing of textiles, that is fiber testing especially, where we are going to discuss about the high volume instrument and then advanced fiber information system. So these are the two latest developments in testing of fibers, especially for its various dimensions. Okay, so today's class we are going to discuss about this high volume instrument. So generally in testing we have low volume instrument and medium volume instrument and then high volume instrument. Okay, so depending upon the spinning industry, that is the size of the spinning industry, they will be having the suitable instruments. Okay, so when it comes to this high volume instrument, so where from the name itself you can understand, that is where you have the volume of fibers to be measured is more. Understand? So bundle of fibers you have to measure at a time. So anyhow we have the other instruments, like we have this fineness tester, we have fibrograph, and we have this Micronaire testing. We have different instruments where it can also be measured. It can also measure the fiber dimensions, the bundle of fiber dimensions. But it is not fast. It is not fast, and the accuracy also not that much. So this high volume instrument is introduced, which is a fully automatic, where it can give us the precise results, that is accurate results, and all these fiber dimension measurements can be done at a single instrument. So that is what the beauty of this high volume instruments. Okay, so if you look at the testing of fibers, so these instruments are used only at the fiber testing stage. Okay, so the testing of fibers was always of importance, very important for the spinners. Why? Because if they don't test their fibers, they cannot take the right measures during their spinning process. So it is done by using this high volume instrument. If you have bundle of fibers are there. Okay. So high volume instrument systems are based on the fiber bundle strength testing. That is, many fibers are checked at the same time. If you have many fibers which you need to examine at the same time, and their average values can be determined. So then it comes the help of or need of this high value instrument. And if you look at the traditional way of testing, like Micronaire testing, and then using Presley's stellometer, and then this fibrograph, are designed to determine the average value of bundle of fibers. But they are not that much fast, and we cannot get that much accuracy. Okay, so in HVI, that is high volume instrument, the bundle testing is automated. So all the fiber dimensions related properties dimensions can be done by using with automation. And here the time for testing is very less. And so the number of samples can be done very high, and it could be processed, can be increased and quite considerably. Okay, so the influence of operator is reduced. When it comes to the traditional instruments like Micronaire and then this Micronaire and fineness, both are same. And then this fiber length, and then by using fibrograph, and then this stellometer, bundle fiber strength. These are the traditional way of finding the bundle of fiber properties, where it is time consuming, and so more manual intervention is there. So obviously, where there might be some deviation in the results. So we can use these high value instruments which are fully automated and which gives the very precise results within less time. Okay. Now, this advanced fiber testing system, high value instrument is used to determine the fiber properties in the bale management system. So this high value instrument is provided with this bale management system software, so which gives the right mix. Okay. So it is a kind of fiber classing system. That is, it is classifying the fibers. HVI is used to determine the fiber length, fiber strength in the sense not the single fiber strength, just like install. Here the bundle fiber strength it is going to measure, and maturity and Micronaire and other properties of cotton fiber, say for example color, that is reflectance and yellowness of the sample. Okay, trash content coverage. Okay, likewise, these sort of parameters can be measured by using this high value instrument. And the HVA test report helps to lay down the same properties of bale before mixing. Lay down the same properties of the bale before mixing. And mixing obviously it is a very, very crucial process in spinning. Okay, so the report, HVI report, high value instrument test reports are there, which helps to lay down same properties of bale before the mixing. So if the bale is having same properties or nearly same properties of fibers, obviously we will get good quality of yarn, and that can be done by using this HVI test report. And if you look at this high value instruments, so we can measure various fiber dimensions. Just now I have mentioned, like we can find out the fineness, that is Micronaire of the cotton, and we can find out the upper half main length, and then we can find out the uniformity index and short fiber content and fiber strength in gram per tex. That is, to break one tex of filament or fiber, what is the amount of load which is required. That is, and then elongation, that is breaking elongation, and moisture content and color. So in color we can find out the reflectance, that is RD value, and yellowness of the cotton, that is plus B value, okay, which corresponds to yellowness. And color grade by using this USDA apply and PIMA regional custom-made color chart, and trash, that is percentage of area covered by the trash, and the trash grade also. And finally, spinning consistency index. Okay, so these are all the various fiber related, that is fiber dimensions, which can be measured by using this high value instrument. So one is Micronaire, that is fineness of the fiber samples, and then we can find out the length related parameters like upper half main length, and then uniformity index, and we can find out the short fiber percentage, and then fiber strength, that is bundle fiber strength, and elongation, moisture content, and color, that is reflectance, and then plus B values, that is yellowness values, and then color grade, trash percentage. Okay, so likewise, various fiber related parameters can be measured by using this high value instrument. Okay, now when it comes to this Micronaire, as you already know, the Micronaire is nothing but it indicates the fineness of the fibers. So here So where this high volume instrument, so which uses this airflow principle to find out the Micronaire values. So about this airflow principles we have already discussed in our previous classes. If the fiber is finer, where it is having more surface area and obviously less amount of air will pass through. And if the fibers are coarser, it is having more, that is, it is having more surface area available, less surface area available, and less amount of air will, more amount of air will pass through. So, if the fibers are finer, where the output is going to be, that is, less amount of air will pass through. If the fibers are coarser, more amount of air will pass through. And based on that airflow principle, this instrument finds out the Micronaire, that is, fineness of the fibers. So generally it ranges from 3 to 5. So 3 to 5 or 3 to 6. So the below 3 it indicates very fine fibers. Below 3 it indicates very fine fibers, and 3.1 to 3.9 indicates fine, and 4 to 4.9 average, and 5 to 5.9 these fibers are coarse fibers, and over 6 it is considered to be very coarse fibers. Okay, so here the Micronaire values can be found out by using this airflow principle. Okay, now when it is coming to the length, so by finding out the length, okay, that is fiber length. Okay, in order to find out this fiber length, this high volume instrument is provided with this, that is inbuilt fibrograph. Inbuilt fibrograph, okay, which we have already discussed in the previous classes. The fibrograph is inbuilt, and we are preparing the fiber samples by using the fibro sampler. By using the fibro sampler, where the beard fiber tuft is going to be prepared, and then it is subjected to this fibrograph, where the fiber samples are going to be scanned photoelectrically from base to the tip, so that we are going to get the concept, that is where it is going to be measured photoelectrically, it is going to be scanned, and from there we are going to get the span lengths, 2.5% and 50% span lengths, and from that we are going to find out the uniformity index. And that ratio of 2.5% to 50% span length will give you this uniformity index of fiber tuft. That is whatever the fibers we have selected. Okay, and here we can also get this upper half mean length. So which is nothing but the average length by number. Average length by number of 1/2 of the longest fibers when they are divided on its weight basis. The average length by number of 1/2 of the longest fibers. 1/2 of the longest fibers when they are divided on their weight basis. So that is called as upper half mean length, and from that also we can find out the uniformity index, where we can use this formula. That is mean length into 100 divided by upper half mean length. Upper half mean length. So mean length, that is average length of fibers, and divided by upper half mean length will give us the uniformity index also. Okay, so and you can see here the uniformity index and the values, and based on the values we are getting, we can from these standard values we can come to know what is the uniformity of, that is uniformity index of the fiber, that is in terms of fiber lengths only, uniformity in fiber length we can say. If uniformity in fiber length is more, obviously we will get good quality of yarn with good mechanical properties. If uniformity index is uniformity of fiber length is very less, or it is deviating much, where we cannot get the right property or quality which we are expecting. So that is the indication of this uniformity index. Now you can see if the uniformity index is below 76, that is it is very low uniformity. That is length uniformity is very less, and 77 to 79. And finally you can see if the value is above 86, we can say that the uniformity index is very high. So where we will get good quality of yarn with good strength. We can say good strength, and we can have less number of breakages also. Understand why? Because the uniformity in length is very good. So there is not much deviations in the length of the fibers. Okay. And coming to strength, as I told you already, here after finding out, that is after scanning the fiber beer photoelectrically from base to tip, and further the same beer, that is the same bunch of fibers, say for example, so this is the comb and these are the fibers which are caught randomly at this comb by using this fibro sampler. So, and before subjecting this comb into this instrument, where these fibers are getting straightened, so it is getting braced so that any loosely attached fibers are going to be removed, and this beard is subjected to the photoelectrical scan. Now, where it is going to be scanned from base to tip, once the scanning is done, where the same beard is subjected to this bundle fiber strand, that is, it is going to be applied, that is, it is going to be break. The fibers are going to be like the load is going to be applied and then the fiber specimen is going to break. So that means here we can get the idea of the bundle fiber strength in gram force. Okay, so in gram per tex. So what is the number, that is weight which is required to break 1 tex of specimen, that is fiber. If the breaking strength, that is gram per tex, if it is below 21, where we can say bundle fiber strength is very low, and if it is more than 30, we can say that the strength is very high. So likewise, we can categorize the fiber bundle strength based on the results we are getting. And coming to short fiber index, so which is nothing but the percentage of fibers shorter than half inch or 12.5, that is, so 12.5, so 12.7 mm. The fibers are the percentage of fibers shorter than half inch. So those fibers are categorized as short fibers, and finally we are going to get the index. So if short fiber content is more again, so where the yarn breakages are going to be more and we cannot get good strength in the final yarn, and it increases the cost of processing also. So the presence of short fibers in cotton increases the cost of processing. Why? Because the short fibers and breakages and the waste, it is going to contribute the weaker yarn and then less efficiency in the spinning. That is, more number of breakdowns, all those things. And longer length of fibers are more preferred due to reduced number of fiber ends with higher yarn strength in the same length. So obviously, the spinner is preferred to have longer length fibers, so to get more efficiency in the spinning and then reduce breakages and final good strength in the yarn quality. Okay. And the thing is, the last one is, and last but not least, spinning consistency index, that is SCI. Okay, a coefficient is calculated, that is spinning coefficient index, consistency index. This is calculated by means of various quality characteristics of the fibers which we are testing, and this can be found out by using this multiple regression analysis. Now you can see this is the formula. You can see here where the strength is considered and Micronaire is considered and length is considered, uniformity index, RD value and then plus P value. So all the fiber related characteristics are considered here to find out this spinning consistency index. Okay, and what for we need to measure this spinning consistency index? So whatever the index we are finding out, its main benefit is a simplified selection of bales for a predetermined blend of fibers. So simplified selection of bales for a predetermined blend of fibers as well as the long-term check of the blend material. Long-term check of the blend material. So the blending process is going to be very simple, and we will get right quality of the, we can place we can place the fibers which is of equal, that is more or less or nearly same properties. Okay. And this yellowness, that is the color, that is reflectance, and then the yellowness value. Okay. So this RD represents the reflectance, and the reflectance is more, we can say that, where the color grade is also going to be high. And coming to plus B, it indicates the yellowness of the fibers. And the trash, so this HVA, it can measure the trash area, that is the area of sample which is covered with the trash particles. And also it gives a trash count and a number of trash particles, that is a number of trash particles in a sample. So this sort of information also provided by this high volume instrument. Okay, so this is all about the high volume instrument and its use in the spinning industry. So most of the spinning industries, so they might be having they are having these high volume instruments to continuously know the fiber properties. Fiber properties like length, strength, fineness, and micronaire, color. Okay, all these values. Okay, so this main advantage we can say is, since it is automized and all the fiber related parameters can be done at one instant, like at a one machine, single machine, where this, because of its automation, where the manual intervention has been reduced or minimized, so that we are getting more precise values about the fiber properties. Understand? So this is all about the high volume instrument. So in the next class, we'll meet again and we will discuss about the advanced fiber information system and its various modules and its use. Okay, so till then, thank you.